right, so this is a special case of a line, and for us to find the slope, we can pick any 2 points on it and then find our rise over run. So remember that rise over run, rise is how far up and down we go. So we're not going up and down at all when we go from point to point on this line. So our rise is 0. Our run is 1 when we move from point to point. So if we simplify that, we get a slope of 0. So our slope m is 0. And as we discussed before, whenever you have a 0 slope, that means you're going to have a flat line, a horizontal line. But this is how you can think it through when you're looking at the line itself. So in this case, we have another special line, the vertical line. So I'm going to pick any 2 points here and look at rise over run. So rise is, in this case, 1 between any 2 points. We're rising 1, going up and down by 1. Our run, we don't go sideways at all here, so our run is 0. Well, we know we cannot divide by 0. That's impossible. So when we're talking about slope, when we have division by 0, we call that an infinite slope or an undefined slope. And so all vertical lines have an infinite or undefined slope. You can say it either way. So that brings us to the 4 types of slope. You can have a positive slope, a negative slope, a 0 slope, or an undefined or infinite slope. So this is also called an infinite slope. So a positive slope is going to lean towards the right. A negative slope is going to lean towards the left. A 0 slope is a horizontal line, and a undefined or infinite slope is a vertical line. And we'll see more examples of this. And a lot of times what I like to think about is a V. And on the right-hand side, this is my positive slope. On the left-hand side, that's my negative slope. And that kind of helps me picture which way the line will lean, if it's a positive or a negative slope. And we'll talk about this more as we graph some. All right, so the first thing I want to talk about is putting equations in the slope-intercept form of an equation. When you put an equation in the slope-intercept form of an equation, you solve for y in terms of x. And so that's a lot of why we were practicing that skill. One, so that we could use the xy tables, but the other is so that we could put our equations in the form that we're going to use to graph using slope. So when we solve for y in terms of x, you actually put it in slope-intercept form. I just didn't call it that earlier. So slope-intercept form of an equation is y equals mx plus b, where m is your slope, and we've already talked about using the letter m to represent your slope, and where b is the y-intercept. Where b is the y-intercept. And so if you look at your line here, b is going to be right here. It's a little bit hard to tell exactly what it is. And then our slope is, we can figure our slope out just like we did earlier by counting between 2 points. So we're going to look at a equation and go ahead and graph this in slope-intercept using slope-intercept form. So solve for y in terms of x, and that will put this equation in slope-intercept form. So go ahead and give that a try. So now we've put the equation in slope-intercept form, y equals 2/3 x plus 3. So the first thing we're going to do is we're going to use the y-intercept, and we're going to plot that point. Okay, the y-intercept is always going to be the constant. So your 3 is your y-intercept. So that means the ordered pair 0, 3 is our y-intercept. We can always look right there and tell that that's going to be our y-intercept. You don't have to write out 0, 3, but just to emphasize that. So I'm going to put a point at 0, 3, or 3 on my y-axis. Then my slope is 2/3. So your slope is the coefficient of x. Once you solve for y in terms of x and put it in this form, your slope will always be this coefficient of x. It's not x, it's just the coefficient. So our slope is 2/3. So what we're going to do is we're going to use that 2/3 and we're going to come into our graph. We're going to start at our y-intercept and go up to 1, 2, and over 3. 1, 2, 3. Then up to 1, 2, over 3. 1, 2, 3. So it's rise over run. So 2/3 is our rise over run. So that tells us that we go up or down 2 and then sideways 3. Rise over run. So that's what our slope is telling us. Now, not only can I go up 2 and over 3 in the positive direction, I can go down 2. What do you think I have to do with that 3 if I go down 2? Right, go to the left or backwards, right. So I can also go down 1, 2, and backwards 1, 2, 3, because that's the positive slope, right? -2 over -3 is the same thing. So I can go down 2 and backwards 3. And usually I just plot 3 points, but I wanted to emphasize that idea. And now you can create your line. Make sure you put arrows on both ends of your line. Which I didn't mean to do with that. There we go. So let's go ahead and solve for y in terms of x, and that will put this equation, which is in standard form, we'll change it into the slope-intercept form by solving for y in terms of x. So you end up with the equation y equals 5/2 x plus -5 when you solve this for y in terms of x, which puts it into the slope-intercept form of an equation. So keep in mind that when you're in the slope-intercept form of an equation, the constant is now your y-intercept. So just putting it in this form shows you what your y-intercept is automatically. And we use the letter b to represent the y-intercept. So let's go ahead and graph -5 as our y-intercept. So that's the first thing you do, is always put a point on the y-axis wherever your y-intercept is. The coefficient of x is m, or your slope. So now that we've started with one point, you always need a point to start with, then you can use your slope to graph. So we're going to come up with two new ordered pairs, and I'd like you to use positive 5/2 and then -5 over -2. Let's use both of those slopes. Let's use both of those slopes to graph. Go ahead and find two more ordered pairs. So here I started with -5, and I went up 5 and then over 2 in the positive direction, and I ended up at 0, 2, or 2, 0. And then I went back to -5 and I went down 5 and over 2 in the negative direction and ended up at -2, -10 for that third ordered pair, third point. Make sure you put arrows on both ends of your line, and then we really should put the equation on the line as well to label it. Okay, so again we're going to solve for y in terms of x, which we'll put this in the slope-intercept form. So you should end up with y equals -2/3 x plus -2. So let's start by plotting -2. So you always start by putting a point at your y-intercept. That's really important. That's the first thing you do when you start to graph. Now we have a slope of -2 over 3. So that means we go down 2, 1, 2, and over 3 in the positive direction. 1, 2, 3. Or we can go up 2, 1, 2, and backwards 3 in the negative direction. 1, 2, 3. Either way, doesn't matter. And you can keep going. Like from this third point, I can go down 2, 1, 2, and over 3. 1, 2, 3. And then we put our line through it and label it. And I want to talk a little bit about this idea of positive and negative slopes and being able to identify them when you look at your graphs. So I can look at, one of the things I do to double check my work is I know what a negative slope should look like. So this is a negative slope. Notice how it's leaning to the left, or however you want to think about it. That's how I think about it. The one before this is a negative slope. It leans to the left. The one before it is a positive slope. It leans to the right. The one before that was a positive slope. It leans to the right. And so that's what I was talking about when I was up here and I said I think of this V and I think of the negative slope as leaning to the left and the positive slope as leaning to the right. And that helps me to double check. So what about this one? Is that a positive or negative slope? Positive slope.